uniform magnetic field of 3000 Gauss is established along the positive z direction. So here in our case, B is equal to 3000 into 10 raised to minus 4 Tesla. In which direction? Positive direction, means it is the direction of K. So I can write 0.3 K Tesla. A rectangular loop of sides 10 cm, 5 cm carries current 12 ampere. So current is 12 ampere and area of the loop is 10 into 5 into 10 raised to minus 4 meter square. So this comes out to be 50 into 10 raised to minus 4 meter square. So magnetic moment M is equal to IA. So 12 into 50 into 10 raised to minus 4. So that comes out to be 0.06 ampere into meter square. So these are the physical quantities given. Now what is the force, what is the torque on each loop, what is the force on each loop, and which case corresponds to stable equilibrium. આટલા આપણે આન્સર આપવાના છે. So in each case magnetic field is in the direction of Z, but magnetic moment is different in different case. So here I take first case, case 1. So here you can see the current direction is anti-clockwise and it is in YZ plane. So magnetic moment must be along the X. So when you rotate the screw in anti-clockwise direction, the screw is coming out. So in case 1, magnetic moment is equal to, we can write 0.06 in the direction of X. Okay. So torque, we know that M cross B. So M is 0.06, B is 0.3. And this is the magnitude. First I calculate. So 6 3 ja 18 1 2 ne 3, so into 10 raised to minus 3 joule. So this is the torque acting on first coil. And what is the direction? So M is along this direction, so I write M is in I direction, okay, and B is in K direction. So I cross K, if you put, so I cross K is minus J, so it is along minus Y direction. So this torque is along minus Y direction. Torque is along minus Y direction. Similarly, now I give briefly. So here magnetic moment is along same direction, yes, in the direction of I only, similar to here. And here also you are getting same torque, okay. And first case and second, there is not any difference at all, just the orientation of the coil is different. Here length and breadth change થઈ જાય છે. So not much change. So B is as usual above, B as above only. Along negative Y direction bhi avse. Now in third case, this is the direction of the current, it is in XZ plane. So magnetic moment will be along Y direction. So if you rotate the screw looking to from Y side, positive Y side, so it is minus Y direction, yes. So here M is minus y direction, minus y means minus j, so 0.06 j, but it is negative ampere into meter square here, ampere meter square. So you can calculate what is the torque as we calculated in D. If you see the D, so this is B is along the, so this is perpendicular to this one. This is the magnetic moment. This out in outer direction, yes, like this. And angle between these two is 90 degree. Okay, yes. So magnitude wise, not change. So angle between this B and this is along in xy plane. So xy plane is perpendicular to Z. So angle between M and B is 90 degree. And this is the direction of torque. So magnitude is same, but torque makes angle 60 degree with x-axis. So in D, magnitude of the torque remains same. That what we have calculated, it is 1.8 into 10 raised to minus 2 joule or Newton meter, and direction of torque is 60 degree with positive x direction, and that is in anti-clockwise. Okay, then our case is E. So here magnetic moment is in upper direction, so theta is 0, so torque is 0. Here also magnetic moment is in downward direction, because we rotate the screw is going down toward the minus direction, so theta is 180, so torque is 0. Okay, see, in all these cases it is a closed loop, so resultant force is 0 on all the 6 cases. In first, second, third and fourth torque is acting of same magnitude but depends the direction. In E and F, torque is 0, force is also 0. Here torque is 0, so it is stable equilibrium. Here torque is 0 but angle is 180 degree, so it is unstable equilibrium. So this is stable equilibrium. This is unstable equilibrium, and rest of are not in equilibrium because torque is acting. Okay, stable equilibrium, theta is 0, theta is 180, so unstable equilibrium, and here torque acting, so these 4 cases are not in equilibrium at all. A circular coil of 20 turns, so N is equal to 20, radius is 0.1 centimeter to convert to meter, place in uniform magnetic field of this magnetic field B is 0.1 Tesla, normal to the plane of the coil. If the current in the coil is 5 ampere, so current in the coil is 5 ampere. Okay, then what is the total torque on the coil? What is the total torque on the coil? So we have formula torque is equal to BI sin theta. So here B is given, I is given, N is given, area. So area we can calculate And what is the theta? The circular coil of 20 tons radius is placed in a uniform magnetic field normal to the plane of the coil. So if a coil is normal, then theta is 0. So torque is 0. I don't want to substitute the value. Here theta equal to 0, so torque is 0. Total force on the coil, it is always 0. For closed loop, force is always 0. So F is equal to 0. Average force on each electron in the coil due to the magnetic field. So here force is acting, see, force on each electron that we want to calculate. So we have formula F is equal to QV cross B. So here EVB. Okay. So we have charge of the electron, we have magnetic field also, but we don't have velocity. तो एक अपनी पास जूनी फॉर्मूला चाहिए कि I is equal to NEVD. मैं तुमने आपेला भी कीधु अवनी sorry, I is equal to AVNE. So V is equal to I upon ANE into B. Okay. So E is cancelled out. So we have electric current, that is the 0.1. Magnetic field is given. Sorry, magnetic field is 0.1 and current is 5 ampere. Divided by N is the number density, that is the 10 raised to 29 is given, and area. So area is equal to how much? Cross area is given 10 raised to minus 5. So 10 raised to minus 5. So if you simplify, you will get force on each electron. 10 raised to minus 25, it comes out that much, 5, okay, Newton. So this is the answer of C. Then a solenoid of 60 centimeter long, 60 centimeter we write in meter, so it is 0.6 meter. Radius is 4 centimeters, so 4 into minus 2 meter, has 3 layers of winding and 300 turns, so total turns in each layer 300, so total is 900. Okay, normal to its x. Okay, a 2 centimeter long wire of mass 2.5 gram lies inside the solenoid, normal to its axis. So it looks like this. This is the solenoid. Okay, here there is a wire. So this wire is suppose this opposite side. So this is the wire, and this is the magnetic field direction. Okay, so this wire carries the current. Mass of the wire is 2.5 grams, so I write in kilogram. Inside the solenoid, normal to the axis, both the wires and the axis of the solenoid are in the horizontal plane, so they are horizontal plane. The wire is connected through 2 leads parallel to the axis of the solenoid to an external battery which apply the current 6 ampere. So here current is 6 ampere. This current is 6 ampere. So I is equal to 6 ampere. What value of current in the winding of the solenoid can be supports the weight of the wire? Okay, so what is the current here? So it produces the magnetic field here, and which gives upward force I LB as we know it, and downward force is mg. So mg is the downward force, I LB is the upward force. Okay, this current is I, and we want to find out B, and from B we can calculate what is the current in the solenoid. Okay, so magnetic force on wire is equal to gravitational force. Okay, so magnetic force ILB is equal to mg, and therefore B is equal to mg upon IL. mg upon IL. But B is equal to mu 0 small ni, where I is the current of solenoid. Okay, and is equal to total number of turns upon length of the solenoid into current in the solenoid. So what we write, mu 0 n is upon L is equal to mg upon IL. So this L and this L both are different. So this small l is length of the wire and L is the length of the solenoid. So what is my IS? mg capital L upon mu 0 number of turns into current of the wire and length of the wire. So we put all this value. So what is the mass? So mass is what is the mass? 2.5 into 10 raised to minus 3. 2.5 into 10 raised to minus 3. Gravitational acceleration is 9.8. Length is 0.6 because it's 60 centimeter. Mu 0 4 pi into 10 raised to minus 7. Number of turns 900. Current is 6 ampere, and length of this wire is what is the length of that wire? Length of the wire is 2 centimeter. So 2 into 10 raised to minus 2. 2 into 10 raised to minus 2. So we simplify this. It gives the current of the solenoid. It comes out to be 108.72 ampere. So this much current is required to balance that conductor. This is our answer. Next, a galvanometer has resistance 12 ohm. So this is your Rg is equal to 12 ohm, and the meter shows the full scale deflection for current 3 milliampere. So this is the current capacity 3 into 10 raised to minus 3 ampere. How will you convert the meter into voltmeter of range 18 volt? So V is equal to 18 volt. So what is the series resistor required? So our formula R is equal to, we have R is equal to V upon Ig minus Rg. Okay. So we substitute V is equal to 18 volt divided by 3 into 10 raised to minus 3 minus 12. So this is 6,000 minus 12. So that comes out to be 5,988 ohm. So this is the series resistor required to convert into voltmeter. So this is our answer. And last one, a galvanic coil has resistance 15 ohm. So this is the 15 ohm. The meter shows full scale deflection current 4 milliampere. So current capacity is 4 milliampere. So it is converted into ampere. how will you convert meter into meter of range 6 ampere? So my aim is to measure 6 ampere. So we have formula of shunt. Okay, RS is equal to IG upon I minus IG into RG. Okay, formula learn करवी फरजियात છે. So for IG is 4 into 10 raised to minus 3 divided by 6 minus 4 into 10 raised to minus 3 into RG is 15 ohm. So this is 6 into 10 raised to minus 2 divided by 5.996. So that comes out to be 10 raised to minus 2 ohm. So this is the shunt required to convert into, this is our answer. So you do more and more practice. Whenever you solve the problem, again you go through it, and whenever you required, you pause your video and think over that, then you move ahead. અવારનવાર સોલ્વ કરશો એટલે તમને ફાવટ આવી જશે અને ફોર્મ્યુલાઓ લર્ન બી થઈ જશે. તો આ ચેપ્ટર અહીંયા આપણે પૂરું કરીએ. સ્ટીલ વી વિલ હેવ મોર પ્રેક્ટિસ ફોર MCQ. ઓકે, ત્યાં સુધીમાં તમને જે મટીરિયલ સપ્લાય કરેલા હોય એનું તમારે સોલ્વ કરવાના છે. ઓકે, થેન્ક યુ વેરી મચ.